We are talking about bisectors of triangles and medians and altitudes, and we want to identify and use perpendicular bisectors and angle bisectors in triangles. So here we have some examples where we want to use the perpendicular bisector theorem. So given line segment CM is the perpendicular bisector of line segment AB. So here we have CM, and that is the perpendicular bisector of line segment AB. So the first thing is we want to show what marks that means. So point C is on the perpendicular bisector of line segment AB. So that means point C is the same distance from A as it is from B. Also, because C is the perpendicular bisector, that also means, or CM is the perpendicular bisector, that also means that AM is congruent to BM. Now we can add some information to our drawing. So here it says the measurement of, or the distance from M to B is equal to 3x plus 14. So M to B, that is going to be 3x plus 14. And then we have AB, which is the full distance, is going to be equal to 52. So AB is the entire length. That is going to be equal to 52. Well, because we know that these two sides are congruent, we can also add that AM is also 3x plus 14. So then we can set up our segment addition formula. So in this case, it's going to be AM, so the distance from A to M, plus the distance from M to B is equal to 52. So we can substitute that in, or is equal to AB, the total distance there. Now we can substitute our values in. The distance from A to M is 3x plus 14, plus the distance from M to B, which is 3x plus 14 again, and that is equal to 52. So 14 plus 14, that is going to be 28. And 3x plus 3x, that is 6x, and we're adding those together. And that is equal to 52. So now we have a two-step equation. We want to get rid of the 28, so we subtract 28 from both sides of the equal sign. Our 28 cancels here. And we're left with 6x is equal to, and 52 is 24. Then we want to get rid of the 6 in front of the x, so we divide both sides of the equation by 6, and we get x is equal to 4. Now we can look over here at example B, and we see that AC is equal to 5y minus 7. So there's AC, that's 5y minus 7. And then we have CB, which is right here, and that is equal to 2y plus 11. So we want to find the length of AC. So we want to find the length from A to C. In this case, we can set up basically our congruent statement. We can say that AC is equal to CB. Then we can substitute in the values that we know. We know that AC is equal to 5y minus 7, and CB is equal to 2y plus 11. So we can add 7 to both sides of the equal sign to get rid of that 7. On the left side, we're left with 5y. On the right side, we're left with 2y plus 18. We want to get the y's together, so we're going to subtract 2y from both sides of the equal sign. And our 2y is going to cancel, and we're going to be left with 3y, which is equal to 18. We're going to divide both sides by 3, and we get y is equal to 6. So that told us what y is, but the question says, what is AC? So right here we know that the value of AC is equal to 5y minus 7. So we're going to substitute our 6 in for y. AC is equal to 5 times 6 minus 7. So AC is equal to 30 minus 7. So AC is equal to 23. And this is the answer that we were looking for. We have one more example to look at. Again, we can mark on the drawing what we know. We know that AC is 24. So it says AC is 24. And we know that AM is 13. We're using the same directions that we had written above, where it says given line segment CM is the perpendicular bisector of line segment AB. So what that means is that AM is congruent to MB, and AC is congruent to CB. So because we know that these are congruent by the perpendicular bisector theorem, if AC is congruent to CB, then they're both 24. And if AM is congruent to MB, then they're both 13. So if we want to calculate the perimeter of triangle ABC, we know that that is all the sides added together. So that will be 24 plus 24 plus 13 plus 13. Those are the sides that we know that will be the entire perimeter of the triangle. So the perimeter of the triangle, the perimeter of triangle ABC is equal to, add those all together, and we get 74.